that. In fact, we'll just do that as well. Whoops, 1 and 0. Hopefully that all makes sense. Now let's run that and see what happens. All right, so here we are. We're able to list them all out and format their values. So you see how much more compact this looks than what we were writing here. We do it all in one line of code. Again, we're passing in for every single item in our collection. Just call console.writeLine and then use that particular item's VIN and sticker price inside of our formatted string. Okay. Here's another interesting example of this. Maybe in each case we want to go so mycars.forEach. In fact, here, let's do this before that line of code. Let's keep that one and then go mycars.forEach. And in this case, I want to perform an operation on each of the data inside of there. So I might take the sticker price and reduce it by $3,000. Actually, let's go minus equal to. So this will take the sticker price and subtract $3,000 from the sticker price of every car in my collection. So you can see now what was, if we could kind of get a comparison going here. Let's see, unfortunately not going to be very easy to do, but you can see that what was $55,000 is now $52,000. What was $35,000 is now $32,000, and so on. Okay. So again, a lot of functionality in a very small space. Let's continue on with this thought and go and do something like mycars.exists. Do we have a car in our car lot where the model is equal to the 745 Li, true or false? And here we'll just do a console.writeLine, and so this will either turn true or false. Yes, we have at least one item in our inventory where the model is equal to 740 Li. Great. Now here's another good aggregate function. Here, let's just do console.writeLine, and let's go mycars.sum, and here we'll say sum up all the sticker prices. Let's see what the total value of our car lot is right now. And you can see that it's about 247,000. So actually, there should probably be a better way to format that using a format code, but hopefully you get the idea. We're able to sum up a single field across all objects in our collection of cars. All right? All right, and there's so many other things that I can show you, but I don't want to overwhelm you. But I want this just to go in one ear and out the other for now. This var keyword we've looked at, and I said that we use it because we want the compiler to figure out what the data type is. Sometimes it's easy for us to figure out what the data type of something is. Sometimes it's not so easy. So to kind of illustrate this, let's do a console.writeLine, and what I want to do is call on my cars, I'm going to call the get type. In fact, all data types in .NET have this get type method declared because it is it's declared on the grandparent of all objects called system.object. It defines this method called getType, which will tell us what the type of a given object is, and we can print it to screen. So in this first case, what is myCars? Well, myCars is a generic list of the car data type. So this understanding link is the namespace, and specifically though it's the car type. So we're basically saying this is a list of T, a list of car, right? So that's what's being printed out whenever we're looking at what the cars are, and that's pretty easy to see because we've defined it here. But once we perform an operation like one of these here, let's just see, ordered cars, we'll copy that again and stick it down here. And then I'm going to do console.writeLine ordered cars.getType, and it'll show us what the data type is for ordered cars. Let's go ahead and compare the two. All right, now in this case, you can see that we're no longer dealing with a list of car, even though under the hood we know we're working with a list of cars. The way that it's represented in .NET is that it's actually an ordered enumerable, so an ordered list of system of the link.car, understanding link.car. Okay, so again, okay, that makes sense. That's an ordered version of cars. How about just a regular old where statement? So let's do that. Let's copy that and see what the data type of that is, and then do the same sort of thing here, where we're going to see what that is. Let's go ahead and run the application again. All right, here's this third one. So this second one was an ordered enumerable. Then the one where we just called the where was an enumerable plus the where list iterator. All right, so things are starting to get a little funky here, right? It might be difficult for us to be able to express this ourselves if it were not for this var keyword. And so the var keyword is essential to help us to be able to create these very complex queries and not have to worry about what the data type of it is that's returned. We know that it is a type of list. It's an enumerable list, whether it's ordered or not, and we can for each our way through it, or whatever the case might be. Now the last thing that I want to demonstrate is I'm going to take this this first query here, and I'm going to pop it all the way to the bottom. Again, if this stuff doesn't make sense, don't worry about it too much. I wanted to go in one ear and out the other, just to kind of explain again the value of the var keyword. In this case, let's change something about this. Let's call this my new cars. All right. And here I'm not going to return cars. I'm actually going to do what's called a projection. I'm going to only take certain values, certain properties of a car, and I'm going to project them into a new data type. What's the name of the new data type? Where am I defining that data type? I'm not going to define the data type. It's an anonymous type. What's the name? I have no idea. It's anonymous. All right. So we can define types at runtime and only choose those properties that we need in the type for the moment. Why may not be obvious just yet, but I want you to understand that there is this idea of what we can do here. So in this case, let us merely let's pull out just a few things, like the car dot make and the car. Whoops, I'm sorry. This should be select new car.make car.model. That's all we want. We're going to leave all the other attributes of car alone. We're going to only take these two values, put them into a new anonymous type. Where's the type defined? Nowhere. We just made it up off the top of our heads. And we're going to save each of those anonymous types into a new collection of anonymous types. All right. All right, so let's go console.writeLine and then take a look at new cars.getType. And let's run the application yet another time. All right, and so this time you can see that we also here have an enumerable plus where select list iterator, whatever that means. But then notice that the data type involves something called an anonymous type that has two attributes, two string attributes, which would be the make and the model. All right. And so I say all of that to say this, that whenever you're working with LINQ, there's a lot going on under the hood to make it all very easy and accessible, but it all depends on defining your types as var, which says we'll let the compiler figure out what the type is. We're not so worried about it because the data type might be so crazy that we can't even comprehend what it is. All right. So hopefully that makes sense. Just to kind of recap the things that we talked about the difference between the query syntax and the method syntax. We looked at a number of different examples of the various LINQ extension methods that were available. We saw how we could kind of break apart an individual lambda expression to better understand that essentially we're saying each item in the collection, run this little mini method against it, and return back a given item that matches that criteria. And then we looked at how to tell what the types were and what the value of the var keyword is, and then we looked at anonymous types. All right, so we covered a lot of ground. I didn't explain everything in great detail, but the key here is just to kind of look at that little formula and try to understand what it needs. Look for examples online. Make yourself a little cheat sheet, and you should be able to utilize these methods inside your own application. All right, so that wraps up LINQ. This will be the hardest thing that you have to think about today, I guarantee it. All right, so that's it. We'll see you in the next lesson. Thanks. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. In this lesson, we will introduce a new decision statement. The if, else statement and the conditional operator are both great. They work best when there's only a handful of things to evaluate. But if you start needing to evaluate many different potential cases, you might find that the switch statement is a little bit more concise and keeps things a little tidier. And that would probably be one of the only reasons why you would use it, and I'll show you a second reason why in this video as well. So we'll come back to the switch in just a little bit, but first I want to talk about a special data type called an enum, or an enumeration. Typically, we want to limit the possible values of a given variable. Now, admittedly, we're already limiting the possible values that can go into a variable by virtue of the fact that we've given it a specific data type. However, even within that, I may want to limit the number of possible values to just a handful. So typically in software development, you want to limit and constrain your data to ensure its validity inside of your system. An enumeration is a data type that limits and constrains all possible values to only those that are valid and have meaning within our system. So, for example, we might want to keep track of a series of to-do items. Maybe that's the type of application we're building. And each to-do item is represented by an instance of a to-do class. And so we may want to keep track of the current status of a given to-do item on our list. And so we may want to constrain the possible statuses to maybe like 5. The task has not been started yet, or it's in progress, or it's on hold, it's been completed, or perhaps it's been deleted. There might be some other statuses, but you can see how I may want to just limit the number of options that are available for a status field or status property of my to-do class. So we could do this a number of different ways. We could just concoct a numbering scheme where 1 is always represents not started and 2 represents in progress. But numbers are, I refer to those as magic numbers. They may have some meaning in the system, but it's not readily obvious if you're reading the source code. You know, as the developer, you may have to look up at some external reference, maybe some code comments, and who knows, maybe those aren't even, maybe they're not even current anymore. Maybe things have changed since whoever wrote those code comments originally wrote them. So I may need to reference or look through a number of different code to ensure that what number 1 means in the system, what number 2 means in the system, and so on. The same thing can be true with strings. I could just use a literal string to indicate the current status. So I could use a literal string, not started, or in progress. But the problem with literal strings is that somebody can mistype them, or they could be there could be a space and not started one time, and then somebody uses not started without a space the other time. And so they may not, if you're looking for all those items that have not been started yet, you may have a hard time finding those that have not yet been started or are in progress because they're not spelled correctly or whatever the case might be. So the great thing about an enumeration is that it gives us a textual equivalent to a numeric value so that it'll remove any ambiguity inside of the system. As developers, we know exactly what we're working with, and yet behind the scenes it's still working with a number. And enumerations are used frequently in the .NET Framework class library for the very same reasons. So for example, you can see here that I have a project, enums and switch, and here again, if you look in the code folder for this lesson, there should be a before and after. You want to copy the enums and switch project from the before folder and copy it into your projects directory so that you can catch up to me where I'm at this moment. You can always pause the video and type all this in if you like. It'd be quite a bit of typing though. You can see that in this project I've already created a to-do class with a description of each to-do item, the estimated number of hours it should take to complete the to-do item. And then notice that I have a status of type status. Where does this come from? Well, you can see directly below I've created an enumeration called status. And I have not started, in progress, on hold, completed, and deleted. Did you notice as I hovered my mouse cursor over it that each of these values are given a numeric value? So not started equals 0, in progress equals 1, on hold equals 2, and so on. If we were to store these values somehow in a database or a text file, those are the values that might actually get stored. However, they will be translated into this more textual format so that when we're actually working with the data, as you can see here in the static void main, as we're creating a new list of to-dos using the collection initializer syntax, here I'm setting the status equal to either completed or in progress or deleted or not started and so on. And visually it's much easier for a developer to work with those options in a more textual sort of way. Now the .NET Framework class library will use enumerations extensively. In fact, even in the console window, if we were to set the foreground color, notice that IntelliSense automatically pops up to the console color enumeration. See, it says enum over there. Whoops, let's see, I don't think you can see that. Let's go up a little bit here. All right, there. Okay, so now you can see the word enum right here. It's console color enumeration, and when I hit the member access operator, the period, it will show me all the colors that we can choose for the foreground color of our console window. So I might choose dark red. Okay, so again, enumerations are great because they are descriptive and they limit the number of possible values for our applications, for the properties of our classes. All right, the next thing I want to talk about is the switch statement, and these two are going to marry together here in just a moment. But a simple switch statement is going to look something like this. In fact, I'm just going to go switch tab tab, and that will create essentially the outline for it. And in this case, we could do something like we can use an individual to-do item and choose its, let's say estimated hours. And so if the estimated hours are, for example, case 4, all right, then we might perform some operation until we hit the break statement. Or we could go case 5, so we could perform something and then we would hit the break statement and break out. There's also a default case that would be the catch-all, just like the else statement in the if, else construct. But the most important aspect of this is the construct of the switch statement. You have the keyword switch, then you have a value, a variable that's under evaluation, and then a series of cases where we would try to match it up with one of these cases, and then we use the colon after that case. We write our code below it, and then we use a break statement to break out and continue on our execution of the code. Now we might choose to, for example, do something like this. This makes a little bit more sense to work with the statuses. So in this case we might go status dot completed. We might do something versus case status dot deleted, and we might perform some operation there, and so on. Now the beauty of the switch statement and the enumerations are that they kind of can conspire together here. So watch what I do. I'm going to type switch tab tab, and then I'm going to go to do, which is each of the items in the to do collection, dot status, and then I'm going to hit the enter key on my keyboard twice. And the second time I hit enter, see the macro that will actually blow out each of the individual statuses so that I can write code associated with each status. All right? Isn't that crazy? And so now I can do here, you know, anything that my business logic would require. I have an idea though. Let's use the foreground color and change it up for each of the individual to-do items. So it can be as simple as this. Let's just copy this and we'll put it here for each of these statuses. And then here at the very end, we will actually then do a console.writeLine of the actual item itself, the to-do dot description. And here we'll change up the color. So if it's not started, we'll leave it as dark red. If it's in progress, we'll use green. If it's on hold, maybe we'll use the dark red. Let's use the red here and the dark red there. Completed. Let's mark those as blue. And if it's been deleted, we'll mark that with yellow. Okay. All right, so now let's go ahead and save and run our application. And you can see we have a very colorful list of tasks that are color-coded by their current status. All right, see how cool that is? All right, so in this lesson we talked about enumerations and why we would use an enumeration to constrain the possible values for a given property of our classes. And we saw how it was used in the .NET Framework class library, one little instance of it here, where they've created their own enumerations. Just be aware of, as you're trying to work with a given class and its properties, always look at, for example, in this case, what data type it is. So this is a data type console color, and typically IntelliSense will point you kind of in the right direction. As you hit the equal sign, it will pop down to that data type, that enumeration, so that you can just hit the period and then you can make your selections there. So that's a really good hint. And then we looked at the switch statement, the structure of the switch statement, where we're evaluating something in between the opening and closing parentheses. We looked at the body, the opening and closing curly braces, the entire body of the switch statement, and then inside the creation of a number of cases, each case equating to one possible value of the item that's being evaluated, and then a colon, and after that then any of the code that we want to write, and finally a break line which will pop us out of that switch statement's body. And then finally we saw that there is a catch-all, the default colon, which we can use to write any code for cases that we haven't accounted for in any of the other previous cases. Okay. All right, so that wraps up this lesson. Doing great. We're getting close to the end now. You feel pretty confident in C#. You've got the majority of it under your belt. Just a few more topics we want to cover, and then we'll wrap this up. We'll see you in the next lesson. Thank you. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devview.com. In this lesson, we're going to talk about handling exceptions that occur within our applications. We'll discuss what can go wrong, why things go wrong, and how to build resilient applications that are impervious to crashing through the use of C#'s try-catch block statement. So when the compiler catches a data type mismatch or an unresolved reference to a class or some malformed C# instructions, it'll refuse to compile your C# code into a .NET assembly until you fix the problem. These type of errors are called compilation errors, and that's not what we're talking about in this lesson. However, there are other types of errors that happen during runtime, or in other words, they happen when the compiled .NET assembly is actually in the act of executing. And honestly, there are countless number of reasons why you could encounter an exception while the application is running, depending on the kinds of things you're trying to do in your application. And many times, these things are outside of the direct control of the software developer. So for example, if your application can't read or write to disk because a folder or a file is missing on disk where it expected to see it, it could trigger a runtime exception. Or maybe the file's corrupt, or maybe the network access to that resource is unavailable, or attempted perhaps to access a database and it couldn't find something in the database that it needed, a table, a column, whatever the case might be, because the structure has changed of the database out from under the application. All of these things and many, many, many more could cause the absolute failure of your application, and the user will see a nasty error message at runtime, and they'll in frustration say the developer. So in some cases the developer may have not even foreseen that could have potentially been an issue, and so if they didn't see that it could be an issue, they couldn't have accounted for it. Maybe the developer, for example, allows the users to type in a country, but the user misspells the country name. Now, maybe they did that intentionally or unintentionally. Perhaps they maliciously use numerical characters instead of alpha characters. But as a software developer, your job is to make sure that you account for all of these possibilities. A friend of mine was fond of saying that 80% of all code exists to solve 20% of all the potential problems that could happen in your application. So generally, software developers should be pessimistic regarding the reliability of everything outside of their control, whether that be input from an end user, any connection to a network, to the file system. Anything that the developer cannot directly control should be held in great suspicion. So again, if you rely on a file or a network resource, you should treat it with great suspicion. If you rely on the user to type data into your application, definitely treat that with great suspicion. It's absolutely evil, okay? So this is the software developer's equivalent to driving defensively. Always code defensively, which means you are always looking for problems all around you all the time. Now, the way that the C# developer codes defensively, or one of the ways in which they do it, is through the use of a try-catch block, and I'll demonstrate that in this lesson. Up to this point, we've been reading, or actually writing, files to disk. This time I want to read a file to disk. We use the same file class like we've used previously. And notice that I already have a using statement for system.io, so it finds it. And this time I want to use the read all text instead of the write all text. And here, let's just go ahead and set this example up. Notice that I've already got a project created called Handling Exceptions. Please pause the video and catch up with me if you like. But here we go, string content equals file.readAllText. And then let's just, for the sake of argument, hard code a location. I'll put this at lesson 22 /example.txt, and then we'll do console.writeLine the content, and then finally console.readLine, like so. Great. All right, so far so good. And now here I just want to demonstrate that this actually will work. So you can see that I created off my root a lesson 22 folder with example.txt in it. Let's go ahead and run the application, and show that there is actually text in that file. It's just a quote from Mark Twain. And now that we've got it working correctly, let's break the application by giving it a fake name, just by removing the E on the end of example.txt. And now you can see that we get an exception. This is a file not found exception, was unhandled. And so I'll tell you what, let's do this. Let's stop the application.